Today we are going to do section 8.2 on page 780. Now in the previous section we looked at graphs of sine and cosine. Okay, here I drew one here. This is the graph of sine. It starts at 0 and it goes up to 1 and then down to -1 and back to 0, and then it repeats this pattern. This is going from 0 to 2 pi. Cosine is very similar in that only difference is cosine starts at the top right here. Okay, so cosine starts at 1, but otherwise follow the exact same path. Okay, it's identical to sine, going down and then going, and then after it gets to this point right here, then it just goes a little farther, and then it's 2 pi because it started late, so it also ends late. So cosine looks like this from 0 to 2 pi, and sine looks like this from 0 to 2 pi. And today we are going to talk about tangent. The tangent is the third function that is extremely important. And if you have to graph the values of tangent after having figured it out, like this chart right here on page 780, you notice there's a chart here. Okay, the value of the tangent can be figured out or use the calculator, it doesn't matter. You will come up with a bunch of values, and if you have to plot it, then you will notice quickly the tangent graph looks something like this at the bottom of the page, where you see something that crosses from going down and then crawl all the way up. So that is the graph of the tangent, and they all look that way. It just have a bunch of lines crawling, going up and then going up and go up again. And it has a tangent, as you can see, it has a bunch of asymptotes because of all the undefined values. Tangent at pi over 2 is undefined. Okay, the reason is because tangent is the vertical divided by the horizontal, and as your line goes all the way to the top, like this, okay, it goes very narrow. So it has a long vertical line but very little horizontal line. So as a result, the tangent will go to is what we say is called undefined, or we can also say it goes to positive infinity on the one side as x approaches pi over 2. See, it has an asymptote there. On the other side, at negative pi over 2, then the tangent becomes more and more negative and goes to negative infinity. But in any case, the point is the tangent graph, we remember it as something that looks like this. It goes, it goes through 0 and just goes down. Okay, it goes up and take off to infinity on top, and then drops down to infinity on the bottom, and then it repeats itself. The tangent then it goes to infinity at pi over 2 or negative pi over 2. Okay, that is this is the tangent. I guess I should write that down somewhere. Maybe right here, tan. All right, so that is the graph of the tangent. So these three graphs are very important, and please memorize them. Okay, and just every time you see them, try to tell yourself to memorize it, and so that you can see it in your mind's eye anytime that you need to remember what does the graph of sine look like. It looks like this. Cosine looks like this. And sine starts at 0, cosine starts at 1, and tangent just drop. Tangent it goes through 0, but it crosses up and then crosses down on both sides. So that is the fundamental graphing that you need to remember, and that basically is what this is all you need to know from this section practically. Okay, or the previous section when we talk about the sine and the cosine. Okay, so let's look at the next page, and the tangent is so now that I've said that, your book had talked about something like I'm now looking at page 781, or something about stretch factor and the period. You do need to know the period. That is, the tangent repeats itself from negative pi over 2 to pi over 2. Okay, then the next part looks exactly the same, and you just keep doing that. And the best way to see that is if you plot the tangent graph in the Desmos calculator. Okay, and also sine and cosine, you should also try to type it into the calculator to look at it. So let's look at the bottom of page 781, example 1. Okay, and we have a certain function, which is the book made up something, 0.5 times tangent whatever. Now so please plot this thing, type this into the decimal calculator exactly as you see it. That is, start by typing y equal to 0.5, tan, parentheses, etc. Type in all of that stuff, and close parentheses. And so if you type all that in, the calculator will immediately draw the tangent for you. Okay, it will probably draw a bunch of them. That is, so if you look at the next page, you see the tangent. And the book only drew one of these things, okay? Whereas in the decimals calculator, there will be another one that looks just like it on the side, and then another one, and then as many as your computer screen can hold. You'll just have a bunch of these lines going up. That's because tangent is, it repeats itself. And so does sine and cosine. And all these things, you imagine that this is being repeated here, 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 and also on this side, okay, the same thing is being repeated and infinitely for sine, cosine, and tangent. But for our to save space, we're just gonna draw one part, okay? Then let your imagination fill up the rest. So this pattern is gonna repeat itself infinitely on both directions. So anyway, so that is example 1. And then of course the tangent has there are ways that you can calculate how wide the period is. Well, I guess the period is now I'm looking at what page is this? 782. At the bottom, the book gives you certain information such as what is the period? Okay, if you have a equation of a tangent equals to y equals a tangent bx minus c, etc., then in that case the period is pi divided by b, and then well, and so on. The domain of the tangent goes only from everything excluding the points where tangent isn't defined. So anything that's multiple of pi over 2, in this case, this is just tangent x. Maybe I should write the x here so that we're not just writing the function without some x. Okay, here's my x's. So the domain for these functions, any old number will do. The domain for the tangent is also the whole real line, excluding any point that the thing goes to infinity and isn't defined. So then it can't be the domain. And also, as to the range of sine and cosine only goes from -1 to 1, whereas the range of tangent can go, being that it goes to infinity both directions, so the range can be anything, okay, from positive infinity to minus infinity. Yeah, so that, and the vertical asymptotes are exactly when tangent when the function inside the tangent equals to pi over 2, because tangent of pi over 2 is undefined, so that's where the asymptote is. Okay, and when the thing just start crawling up, crawling through the roof and never come back. So that is that. And that is all really you need to know about this. So next, let's look at example 2 on the following page 783. The book has an equation of some tangent function. Please type this into decimals calculator, including pi. Okay, there are ways to type pi in the decimals. You can just type in pi, the two letters p and I, or you can open they have a little keyboard symbol in there, where you click it and then it'll open up and you'll be able to type in symbols such as square root or pi is in there, or e. All those symbols are in there as well. But anyway, so please type this thing into the decimals calculator, and after you're done, stare at it for a few moments, and then that will be, and that's good enough. Okay, all this other stuff is, and let's not wear ourselves out doing all kinds of odd junk, because something like phase shift is not that exciting. I mean, I don't know anybody that cares about that kind of stuff. So let's move on, okay? The next thing is example 3, where you identify the tangent function from a graph. Okay, please look at this example and do it yourself, okay? The way to do it is, first you identify the period which is where does this tangent, where does the stuff inside the tangent equal to pi over 2? Because that's where the asymptotes are. And then secondly, you plug in the point or something. So please do example 3 yourself, okay? That shouldn't be too much trouble. And then we're moving on to the other 3 functions. Now, sine, cosine, tangent are the most important functions. There are 3 other functions. Each one is the flipped over of the original function. That is, cotangent is 1 over tangent. Secant is 1 over cosine, and cosecant is 1 over sine. The 3 functions, well, their existence is out of habit, is a tradition. There's no real need for them to exist, because we can just use sine to express anything that need to be cosecant. So then, as a result, with their graphs are not that exciting. Okay, I have so let's look at the graphs. Let's see. Look at the, where are we? Look at the next page, 785, where there is the graph of the cosecant. Sorry, this is just the secant. Okay, so let's look at the secant for a second. The secant is a bunch of stuff that the blue lines are the secant. No, not blue, black. Well, whatever lines that looks like a U shape upside. Okay, there's a U shape there and a U shape there. That's the graph of the secant if you are to type it into the calculator. And that's all you need to know, because, well, people don't use the graph of secant. I mean, I haven't given any thought about the graph of secant, in the last, for years. And I just went through teaching calculus 1, 2, and 3, and have never considered the graph of secant, like not once. So that is and that is why I say that let's not spend too much time thinking about the graph of the secant. Now, so turn over to the page, then we get to example 4, which is on page 787. Anyway, example 4, it gives you a formula of some secant function. Please type this thing into the Desmos calculator. And then the Desmos will plot out the secant function for you, and you can stare at it a little bit, like it looks something like that. And then that's good enough, okay? And so next, example 5, the same way. Please type this into the Desmos calculator. It will show you what the thing looked like. And where is it? Yeah, it will probably show you something like that, and that's good enough. Secant function looks, it's not necessary to even remember what a secant function looked like, because I haven't thought about it for years. And so how important can it be? Anyway, so next example 6, and then we're doing cosecants. Cosecants looks just like secants, because for the same reason that cosine looks just like sine, except it got moved over by a certain amount. So other than that, so example 6, okay, here's a random cosecant function. Please type this into the calculator, into Desmos, exactly as is, and then stare at it for a few moments. It will look, here's the next page, it will look something like this, except repeated, okay? Your Desmos calculator will be full of this stuff. It will be another one, and then another one, and on both sides. It will be repeated. Let's see what happened. Oh, yeah. So it will be repeated. You see a whole pattern of this stuff, and all the way across your computer screen. But that is what cosecant looks like. And then, so next, example 7, which is on page 790, the same thing. Here's another cosecant function. Please type this into your calculator as well, okay? And then when you're done, then stare at that, and it should look something like this. This is the following page where we stare at here's the cosecant function, and it looks very much like the secant function, except its location got moved by about pi over 2 or something like that. And okay, so the next thing we have talked about the cosecant and secant. So the only one thing left that we haven't talked about is the cotangent function. The cotangent is 1 over tangent. Okay, so what does the graph look like? Well, if you type it into the Desmos calculator, you will see it right away. And I'm now on page 792. The cotangent function looks like this. And so it looks very much like the tangent function, except that it goes down the other way, okay, because it's 1 over tangent. So it goes down the other way, but otherwise, yeah, well, it's not necessary to remember the cotangent function. Then what matters is that you remember what a tangent look like, and the sine and cosine, because they will be important. I've thought about what the sine, cosine, tangent graphs many times during when I was teaching calculus 1, 2, and 3. So the sine, cosine, tangent are extremely important. Although there are periods or phase shifts or something that I have never considered. Okay, that's not that big a deal. What matters is you know what they look like, and that they go up and down and all that. That's the most important part. And that the tangent goes, straight up to infinity and straight down to the infinity. All that you need to be very familiar with. So that is that. So next, example 8. What's this? Oh, example 8 is a cotangent function. So please graph it into the Desmos calculator. And here it is, y equal to something. If for some reason you don't have access to Desmos or anything like it, then you can use the graphics calculator if you have one. If you don't have that either, then just stare at the book. Okay, that's good enough. Because I didn't have any of this when I was a kid, and look at how good I turned out. So it's not they are fun, but they're fun to do if you can. Okay, if you can get the Desmos calculator, which is free, and so if you can type it in, please do so, because it's great fun to watch the graph show up on the calculator without you having to lift a finger to do it. Because besides typing it in, because yeah, that's much better. Yeah, imagine my day when I didn't have any such thing, such as graphics calculators. So back then, what I did is I stared at the book. Okay, I did not go around plotting this thing by hand. No way. I mean, who wants to do that? How boring. So next, example 9. There's some other yet another cotangent function. Please type this into the Desmos calculator. Okay, and stare at it for a few moments once you've done it and see what this thing looks like, and compare it to what's in the book. If what you type in is significantly different from what the book shows, you probably typed in something wrong. So double check your typing. All right, and we're gonna skip example 10 because that is of no significance. So then that's it. For this section, there will be no homework. And so please just do examples 1 to 9 and type in those things and then look at them just to familiarize yourself with the graphs of, just to look at it because it's there. Okay, but what matters is, always remember, what matters is sine, cosine, and tangent. Those are the most important things, and they are extremely important in math. Okay, they will be mentioned many times in calculus and beyond. So, and that's where trigonometry is extremely important. And the sine, cosine, tangent are far more than just their graphs. And we'll go to the next sections where far more exciting and interesting things will happen with sine, cosine, and tangent. So that marks the end of this section.